Alright, looks like we have initiated a video. Okay, so I guess we don't need this, and we'll just get to the story so far kind of thing. So, a while back, as a consequence of just what is obvious from, doing simple playing with a lever or a balance, one observes, okay, that you can have this circumstance. There's the fulcrum. You can have a 2 mass hanging here. You can have a 1 mass hanging here. And you can observe that it oscillates perfectly because basically what you've done is you've increased the weight of this object. This object from this side sees a 2 mass. That's now its weight. If you measure its weight, that's what it would measure. So I could put a 2 here. Or I could put a 1 here, and from this side, it's always going to feel like a 2, okay? That's what I'm going to feel if I put my little finger on here. Oh, it looks like a claw. And press down. If I have a 2 here, I'm going to feel, say, 9 pounds. I like using that for some reason. And if I take that away and put the 1 mass here, okay, it's going to be 9 pounds. That's what I'm going to feel. So that's the argument, because of the way it has to move. Okay, this location does oscillate this much. This side does oscillate this much. This out here oscillates this much. This side oscillates this much. Those are all fixed quantities. You can't change them. You can't make up some other rule because some other rule won't work. Okay, the thing can't do it because this is not bendable. It can't move a different way in time. So when I press on this has to move exactly as it's going to move to be 9 pounds. This has to move exactly as it's going to move to be 9 pounds. That's just, logical. And it's sort of an escapable logic, in my opinion. You can't escape it. No one's going to draw you this image and explain to you how it works some other way. Okay, now they use the word inertia. They think this object has more inertia. Whatever the hell inertia is, right? Inertia is something that only happens on Earth, okay, in friction. If I've had a box that weighs 10 pounds and it has friction on the surface, then it's hard for me to initiate its movement because it's stuck to the ground. It's literally stuck to it. But if I go up in space and there's no friction, there's no inertia. Okay, the thing will move freely, everything moves just fine. It's only this rubbing friction problem caused on Earth that requires you to put in extra energy to get something going, because there's this sticking force. But without the sticking force, if you make it perfectly fluid, like an air track or something, in the sense that it floats, no inertia. It's not a real thing. Absolute silly, childish drivel. It's not a real concept. Alright, so there's no resistance to this moving any more than there's a resistance to this moving. It's just crap. Alright, so sorry. It's crap. Alright. So that's what I said. Now they keep doing these dopey experiments. They won't do what I said, which is, well, look, if you had a person and they couldn't see what you were doing on this side, they could switch the 2 for the 1 all day long, and you would have a 50-50 chance of guessing the right number, but you wouldn't know. Because this is going to be 9 pounds, and this is going to be 9 pounds. They're both going to feel exactly the same, pressing on the same point on the lever. They're going to feel the same. It really doesn't matter where I press. They'll feel the same, but they'll feel heavier if I press out here, and they'll feel lighter if I press out here. But if I press on the same location, these two objects will, in fact, weigh the same. All right. So this is the experiments they're doing to prove me wrong, okay, which will have nothing to do with measuring, like putting a scale over here, and pushing a scale down to see how much this weighs, or pushing a scale down. We know how much it weighs. We already know what will balance perfectly is I just put a 2 mass right here, and it balances perfectly. I put a 2 mass right here, and it balances the 1 perfectly. We already know the answer. We already know how much it weighs. All right. So the pathetic lying sack of smelliest shit there is, this wishy-washy, I'm just going to make noise, jackass, this dispar puke, has made, posted another video. So he claims he's not in this for any other reason than to find the truth and all that kind of crap. And clearly, that's not his agenda. And it's just disgusting that he can just sit here and lie about what he's doing. So he's posted some stupid fucking video. Again, the same redundant crap done badly. So the same poorly done non-clinical experiment. First with no control, right? Now they could at least, if they're going to do these lever experiments, maybe they should show us doing it with the 2-mass and the 2-mass and getting exactly the same oscillation each time. They should do the control experiment first to just prove that the mechanism they're using is reliable, that each time they let go it oscillates at exactly the same speed. They don't do any of that crap. No standard release, nothing, just crap. So the first issue I would have with this piece of shit video. So again, it's just another piece of noise. I mean, he's not smart enough. He doesn't know any of this physics. He doesn't understand any of it. He's just injecting himself because he thinks he's got something to contribute when he has nothing to contribute because he doesn't understand the subject. He can't talk about the theory. He can't explain how it works. He's just injecting himself as if he, can do experiments well. I just decide I'm a very good driver. Well, you're not a very good driver, okay? There's no evidence you're a good driver. All right. So the first thing I noticed was this isn't centered. So the two experiments, this little connecting thing isn't in the same position, which means this isn't in the same position, which means this isn't in the same position. So who knows? Who knows if the lever is even balanced in the sense that he's just balancing the weights on a lever that might already be in balance. The stick might not even be balanced. All right. But well, I don't know whether it was actually that was the first. The first thing I noticed is that he can't even figure out how he's supposed to do the experiment. So you're supposed to put the same weight in both experiments. So instead of doing so this one's the way he's supposed to do it. 2 batteries on one side, 1 battery on the other side, twice the distance. That's what he's supposed to do. And then he's supposed to take 2 batteries on one side and 2 batteries on the other side. See, if you add up the weights here, they don't add up, right? This adds up to, twice as much total weight from the lever's perspective as this one. This one just has a 1 and a 1. This one has a 2 and a 1 at the 2 position, so it's 4. So this one's total weight is 4. This one's total weight is 2. So we can't even figure out they're supposed to have as weights, okay, not masses, as weights, the same weight on the lever, the same total weight. And then you'd also want to lift the side that doesn't change any, right? So the side that has the 2, this should have 2 batteries on it, this one has 2 batteries. That should be the same side on both of them, so you're sure you're injecting exactly the same energy into the oscillator. And then they just do this thing like they somehow have proven something, when you can see there's a huge difference right at the beginning. So let's just play the beginning, because you can see that right from the start it's way off. Okay, and that's sort of an indication of, where the hell's the other picture? There it is. Okay. Oh shit, I mean, if it's that far off from the very beginning, if it keeps doing that through the whole thing, there should be a huge difference in the oscillating number But it turns out after 16 or 17 oscillation that there's only a difference in one oscillation, pretty much 1 or 2 maybe. 6 to 7 kind of ratio. All right. But you can see that from the very beginning. All right. So one of them's almost half there. So that one's just went over the half mark. This one's lagging behind by at least 50% of one revolution. So you can understand if you did that over time, you should have a bigger differential over a few oscillations. But again, this isn't what does this demonstrate? What are you trying to prove exactly? That one circumstance has less energy in it than the other circumstance. It's not changing the 2-to-1 relationship. It's not changing what I'm saying, which is if you pressed on it, it's going to weigh the same. You're not going to be able to tell the difference between the weights. So this in no way counters my argument at all. You provide no theory to explain why exactly it would oscillate at a different speed. What exactly would be the cause of this loss of energy? I mean, do they explain it? No. Do they offer any connection? No. Nothing. They just do this, as if this is what I suggested. This is measuring how much something twice the distance and half the mass weighs. This is how they're proving it somehow. That's not what they're doing. Okay, so anyway, so again, the center isn't in the same place here for whatever reason. You should be able to see that. It's not the same center. So I don't even know what he's hanging it by. We don't get to see any of this. We don't know if these were measured distances or whether he just put the objects where they actually balanced, which is a little different than explicitly measuring them. Are they taped to the lever? Who knows? But obviously when I did the lever, I pointed out how I had them on magnets, so the objects were always just hanging. And so the idea is you want to just hang a weight on the stick. The weight can't change its weight. It's gravity. The weight collects gravity and it puts a weight on the lever. That's what you're supposed to be measuring, is the difference in the weight. So you either put it on top of the scale or you have the scale. Look, there's two kind of scales, right? The little things that balance, and the levers below them. That's one version of the scale. And the other version is you have the stick and then you have two baskets that balance below the stick. So do it right or don't do it at all. But what are you proving here? Okay? Explain it to me why you think this proves something. You're saying this means something. All I can figure is it means, well, if it's oscillating slower, it has less energy in it. Because one of these batteries isn't weighing what it should be weighing, right? It's going a slower velocity, so it can't possibly be weighing what it used to weigh. So you've got less energy in your system. And you're saying somehow that proves something. What does it prove? Explain to me what it proves or what it demonstrates or how it demonstrates it. Because I see absolutely zero connection between what you're doing and what I said. Okay, so if this is your counter argument, it's a counter argument to some other question, because it's not a counter or some other statement, because it's not a counter statement to anything I did. All right, so he has no commentary. He just posts this. So this is, he says, oscillating lever test, whatever the fuck that is. I don't think I said oscillating lever test. I didn't suggest an oscillating lever test. I think the oscillating lever proves the point. The 2 mass, okay, equals the 1 mass in its weight. That's what the oscillation proves, is that the two things are in fact equal, and that's why it oscillates. It would fail to oscillate if it wasn't balanced. So, fuck. Anyway, but what does this mean? Test number 7. Where's test number 6? Where's test number 5? Where's test number 4? Where's test number 3? Where's test number 2? Where's test number 1? Where the fuck are all those tests? What the fuck were those tests? We're just given test number 7. What does that mean? What is that? Why is it in the title? Why should we somehow know this means something? Number 7, test number 7. What were the other tests and what were the results of the other tests? I mean, it's so fucking dishonest. So, we'll read the Brozo comment. But just, these people are just such shit. They're just such, just keep playing your game. Go ahead. You're just proving my point to me. Okay, you're proving the point I'm trying to make. Is that this is why science is broken, is because people actually suck. They all have agendas. They all have points to make. They all are trying to do something other than actually find the truth. That's not the agenda. All right. I just hate people. Hate them. And I hate them for good goddamn reason. Dishonest sacks of fucking goddamn stinking rotten shit. Yeah. Let's see, is this on? Let's see if it's on. Yeah, it is. Okay. So we'll just put it down there for now. All right. So back to the other crappy thing. Yeah. And we'll do the comments. The one comment by the Brozo is that will illustrate the point pretty clearly also. The dishonesty of these people. All right. Yeah, I think you can see that. All right. Did I count right? Question mark. I got 16 for the upper and 14 for the lower. Right, so that would be 7 to 6, something like that. Counting to the point of the upper video went black. Yeah, well, whatever. And that proves what? One of the levers has less energy in it. One of them only has 2 batteries, one has 3. One of them has 2 units of weight, one has 4 units of weight. Yeah. Anyway, this rearrangement of the usual one we have probably done to death. Yeah, done badly. So let's just point that out. Every one of these things has been done in some stupid way where they don't even have whole levers, and they got springs, and they got this, and they got that, and they're somehow proving something, and there's no, this isn't how you do a proof, frankly. It is quite interesting, but still results in a slowdown of the one with the furthest out mass. So, and again, what's the argument? We don't conserve momentum. Is that the argument? So what are you asserting? Where did the energy go? You have to explain that kind of stuff. You can't just say, oh, there's less energy in one of them. Why is there less energy? Well, obviously in this case, there's less energy because it's 2 mass against 4 mass. Yeah, because he didn't do the experiment right. Oh, that's so funny. By usual one, I mean the one where we simply have one of the masses and move it out twice the distance from the fulcrum. We do? I didn't know that was an experiment where you take the same mass and move it twice the distance. I didn't know we did that one. Somebody did that one? I don't know what he's talking about. I once tried suspending from elastic bands. He didn't show us that. Okay. And although there was no appreciable stretching, it did cause the whole lever to wobble side to side a little. So we didn't, these are experiments we don't get to see. So let's just understand, they do a bunch of experiments we never get to see, especially Brozo. You can always see in the background, he's done all kinds of different experiments, and we never saw any of them. Which is more noticeable when I put a big sheet of card to obscure one side. Gary's blind test. Yeah, well, there's no point in doing the blind test unless you actually do it with a blind person. One of you has to know somebody else who can stand on one side, and you do the little changing, and then they predict which way you changed it. Gary's blind test, where he claimed it would be impossible to tell which was balanced I don't know what that is, equistantly from the fulcrum versus one balanced with half the mass twice as far out. Yes, half the mass twice as far out. So that's right. I'm saying, what's the theory for being able to tell the difference? Just explain to me what your theory is. All right? I mean, the lever oscillates perfectly with, the this one moving twice the velocity, exactly twice the velocity that this one moves at. So if they weigh the same, they balance the same weight over here, say 9 pounds. They balance that perfectly. Well, this one has to move twice the distance that this one has to move, and those movements are duplicates of each other. In both cases, this part of the lever moves this much. In both cases, this part of the lever moves this much. If I have the 2 mass here, this part of the lever moves exactly the same as it's going to move if I put the 1 mass out here. That's how it oscillates. It oscillates perfectly duplicating the same position. The lever has the same position. It couldn't oscillate otherwise. So what's your theoretical ground for saying that somehow the lever doesn't oscillate the same even though it's the same weight? How's that possible? There'll be no explanation. All right, impossible with twice as far out. So my elastic suspension kind of spoiled the test a bit. Yeah, I don't know why somebody would think putting an elastic band on the scale would make any sense, but whatever. Even though I got substantially the same outcome, the one furthest out going measurably slower. So again, they're saying when the one mass somehow has more inertia. So it does this magical thing where the 2 mass does want to move, but somehow the 1 mass doesn't want to move. I mean, there's no evidence that bullets have more inertia leaving the gun, than the gun's recoil. Why in this case is the lighter thing more inertia? Anyway, thumbs up. So he gave this piece of shit, again, another non-clinical, not very exact experiment. He didn't show us any controls. It's just who knows what he did exactly. Thumbs up. More noise experiments. That's what science needs. Make more noise. Because in all the noise, then we can believe whatever the fuck we want. We can believe in gremlins now. It's just, fuck these people. It would be interesting to see if it made much difference being suspended by something which couldn't possibly move side to side. I don't even know why this is even an issue. I didn't have a big problem suspending it 10 inches on a piece of fishing line. It didn't do all... I didn't have that much problem with it moving all over the place, so I don't know exactly why you can't seem to oscillate a lever without it moving all over the place. Even a little. So yeah, who cares if it does, actually, frankly. I mean, if it rotates, who cares? That rotation isn't going anywhere either. But whatever. I only wonder because one test I did suggested by Michael Falwell, where I use very heavy masses, so we didn't see that either. See, it's another experiment. Why didn't we see any of that? Why don't you video? I'm sure he does videotape his experiments. Why don't we get to see those clips? It'd be interesting. We all could learn something. But no, that's not important. Okay, that's not part of the experimental process. It's all about the propaganda, not the actual process. Large lead balls and an identical one run. So here he does this capitals again. And an identical one run on the same spindle. What the fuck could that mean? He put it in capital letters, so I'm assuming everybody's supposed to know what that means. And an identical one run on the same spindle. fuck if I know what that means. But using a far lighter mass, pool balls about 1/10 the weight. Who the fuck knows? So this is another experiment we didn't see. I quickly learned that the way I attached the balls to the bar made a massive difference to the speed of oscillation. Well, there you go. See, so he learned something, that, you know, dangling a weight where the weight doesn't move with the bar, okay, it just sits in gravity and produces a pressure on the lever. The idea is for the weight to always be the same gravitationally. And then what you're changing is where, you know, the position on the lever it's pushing, but it's always pushing with the same gravitational weight. Yeah, that's the idea. And it doesn't allow it to push through the lever. It's pushing on the lever. That's what you want it to do. But whatever. I.e., at first I tried lead balls with string. Alright, so we didn't get any of that. We didn't see any of that close to the bar. I don't know what that means. I guess fulcrum. But without realizing that the fact that they could swing sideways drastically slowed down the oscillation. So is that so there's more stuff to recognize here. So somehow some sideways motion, I'm just not sure what he's talking about, somehow consumed the energy of the system. Be interesting to see how the sideways motion could do that, but whatever. I concluded this by firmly taping the balls in place so there could no swing at all, and then the lever sped up a lot. So he's basically arguing that the closer you put the weight to the bar, that is, you stick it to the bar, all right, it's not quite the same as a scale. It doesn't work quite the same. So this is the center of mass argument, that if you bring the weight all the way to the center of the mass of the lever, then you're combining the lever's weight with the weight you're placing on the lever and changing its center of mass. All right, and the point of Michael's proposed experiment, question mark. Yeah, well, we don't know, right? And we don't know, and you did the experiment and you didn't show any of it, so blah, blah, blah. Anyway, well, he proposed that perhaps we could test whether these things should fall under the heading of pendulums. Who cares? I mean, obviously, when I did the experiment, I pointed out how the advantage of me using magnets is the weights always are in the same position. They're always hanging down, okay, in gravity. So they're always applying the same consistent pressure on the lever. So I would argue that, yes, that's probably the way you should do it. And you want to figure out some other stuff about levers, that's your business. But if you want to argue my points, then you should at least concede that I did it a certain way for a reason. By seeing if they could match the behavior of the pendulums in respect to changing the mass of a given pendulum's length does not alter the speed of the oscillation. And part of that's in this theory. The same sort of argument can be made that it's, frankly, it's the velocity component. And you're just basically saying you're doubling the velocity of the outside of the lever, okay? And so it's always going to be that 2-to-1 relationship if it's 2-to-1 distance. So in a way, it shouldn't matter what the weight is, because it's just going to be a proportional change in the velocity. All right. So he suggested that if we have two identically balanced levers, like either of the above examples, and made one of them with far heavier masses, then they still oscillate at the same speed. All right, so that's a question, that I got, I've messed this up before, right? Newton figured out all this stuff. So if you change the length of the pendulum, then you'll change the period, but the same mass will take the same time no matter how much energy is in it. So if you put a tiny amount of energy, it oscillates. The speed of the oscillation is the same as if it has a lot of energy. So it's not so much about changing the mass as it is, as the energy dies out, the oscillating time is the same. And we make one of them, okay, well, anyway. Well, he was right, they did. So we didn't see that experiment. So he proved that if we have identically balanced levers, like either of the above examples, and we make one of them with far heavier masses, they should still oscillate at the same speed. So we didn't see that. So he did an experiment where he had, I guess, lead balls oscillating, and then he had cue balls oscillating on another lever, and they oscillated at the same speed. Presumably in the same configuration of two mass, same distance. He didn't try the one mass further out thing, see if they oscillated at the same speed. Well, anyway, so it's an experiment we didn't get to see. So he has his own little special reservoir of knowledge he has gained from his own little experiments that he's done in private. Okay, but not until I corrected my mistake of allowing the balls to swing sideways a little. Still don't know what sideways a little means, even though it wasn't obvious to the eye that they were doing that. Yeah, so who knows what that is. Alright, so just, yeah. So again, what are they attempting? The clear point I would make is if they're correct, and somehow these things don't do exactly as I pointed out, that they have to move in these certain configurations, the only explanation is they have to violate conservation of momentum. So their theory is that there is no law of conservation of momentum. So that's what needs to be understood. This context is basically saying, they're going to prove the theory of conservation of momentum. They're debunking that. All right, and there's such a huge distance between these experiments and my simple statement that if a one mass twice the distance on the lever weighs the same as the two mass half that distance, they're obviously getting nowhere near proving that statement to be incorrect, and they're getting really, really close to saying we're going to prove there's no conservation of momentum. We are going to destroy the energy. They're saying it pretty clearly. Alright, anyway. So, that's the video. For what it's worth, which is, it's worth nothing, frankly. You couldn't read that. Isn't that too bad? Oh, I guess you could. I moved it. Alright, so enough of that. And we'll see if there's any comments in the next 5 minutes or so. And if not, we'll just call it a video. I can show the simulation again, just for fun. I still gotta get the guy to fix one thing that he hasn't done yet. Blah 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 blah. But whatever, it's working for free. So isn't that just beautiful? Anyway, yeah. All right, we'll start it over so it can go from more chaotic arrangement to order. But anyway. So let's see what else is there. I guess I could move that over there and such, and then we'll pop the chat. Well, you can see it already, so I don't know if I have to. There's no comments yet. All right, so I won't bother seeing how many viewers there are. Just see if we can. Oh, why is that broken? Interesting. Oh well, I'll fix it later. Alright, so nobody in the chat yet. So I'll give you the 2-minute warning or so. If nobody has anything to say, I'll just move along. Anything to question? I mean, there's only so much you can say about levers. Mindless Marbles has, he hasn't made a reply video, but he's made plenty of comments saying I'm distorting Brozo's pool ball experiment and all this kind of crap. And I'm just saying, go watch the video, okay? I mean, I'm not going to link to it. I'm not going to support the moron. But I'm just saying, if you watch the video, you're going to see that the object twice the distance and half the mass is clearly moving substantially faster than 0.4 faster. It's going a lot more than 0.4 faster. A lot more. Now, I could take Brozo's shitty... See, Brozo films the shit. He gives you 4 seconds of this, 4 seconds of that. You have to cut it all to pieces to try to superimpose the two images. So I could try to take the video of when he, the real video of when he launches the 2 mass and then try to find the real clip of the 1 mass. But frankly, he's already edited the video to pieces, so the frame rates are all off and all that kind of crap. But if you watch them side by side, I mean, it's kind of clear that the 2 mass is only going to go half the distance in the same time that the 1 mass is going to go twice the distance. And it's really quite obvious. So I don't even see any room for argument on that score. I mean, Brozo himself acknowledges that the outcome isn't what kinetic energy would predict. Now, he blames nonsense that there was a whole bunch of energy caught up in the 2 mass had some rotation, and the angular momentum of the rotation stole a big giant pile of energy. But I think if you have a brain, you understand that there's no way that minor amount of rotation could have added to anything. It's the rotation it acquired on a piece of glass. So a billiard ball going across a piece of glass, you could sort of understand it's not going to gain a whole lot of angular rotational momentum. It's only going to get rotating. It's not going to rotate consistent with the surface it's rolling on. It's going to rotate at a much slower speed than the actual sticking to the surface like a rubber tire. It's not making very good contact with the glass, and so its rotational speed won't be matching its linear velocity. But whatever. More details these people couldn't care less about. Really is terrible. This is what. So I'm just saying though, but it does illustrate why humans suck at seeking the truth. Because they do it with an agenda. And it's everything you see science produce is being produced by people that have an agenda to produce it. Their goal is to prove the thing. And then they find a way to make it look like they proved it. So instead of these people advocating for kinetic energy, showing us a volume of information, showing us it taking 4 times the fuel to go twice as fast, they don't have that experiment. Showing us a decisive experiment where when they collect twice the velocity at half the mass, and a full mass at half that velocity, that it compresses the spring of the same amount. Brozo tried the experiment and got a number right in between the 2 theories. Didn't confirm anything. Just a fact. That's how it came out. So they just keep talking all this shit, and there's no, it doesn't, they don't produce the evidence. Alright, still no comments, right? Yeah, nope, nothing. Alright, another 2-minute warning. Yeah, another 2-minute warning. See how generous I am? So that is the problem with these live rooms. It takes too long to acquire an audience. So I guess I could schedule them, but I really don't want to do that. is every day is a new adventure. You just don't know. I don't like to make appointments and then not keep them. And such. Well, look at that. See, just proton, electron, proton, electron, proton, electron, proton, electron. Just every single time. Yeah, does the same thing. Monopoles, dipoles. The rest will just be creating enough pressure to create the stable geometry, and you know, I'll start creating elements, and then compounds, and then little human beings will pop out. Just a matter of time. Probably won't have enough time to do all that, but who knows? Sorry. Do notice some little things do make awful big sounds, but you know, it's part of the liability. Alright, so I guess we'll concede that we just don't have the audience, so we have no comments, and so we'll call it a video and such. So, till the next time, blah 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 blah, blah blah.